So today I just wanted to go over some things that I go over when I'm talking to students in doing the design training. And one of the things they often are eager to talk about are active surveys. Because as most of you know, if you do wireless surveys, we have basically two types, right? A passive, where we're listen only and we're listening to what's around us, and we have active, which means you're connected, you're associated. And what I tell my students is that passive is really where you get the data that's really going to make sense to you, because it's a holistic view of the network, right? You get to see everything that's around you, not just your APs, but your neighbors' APs and potentially rogue APs, right, that are in your environment that maybe shouldn't be, all those kinds of things. But I wanted to talk a bit about active surveys in particular. So what are active surveys? So active surveys are surveys when you're associated to the access point and you're transmitting data, right? So that could be a ping, that could be iPerf, something like that, a speed test of some kind. The issue with that, of course, is, as most of us have learned over the years, is that since you're connected to that one AP, all you're getting is the data from that one AP with your device that you're using, right? And when you're transmitting that data, it's where you're at that time, at that location. There's a lot of variables in there, and the data that you're getting may or may not be useful because you have no context for it. So first, let's talk about the ugly, right? So an example of ugly would be, I'm going to survey, and this was a while ago. I go to survey a location, and I had my ePerf server set up on a netbook, and I had it plugged in, and I was doing a throughput test throughout the survey. And when we got together to go over the results, the issue, we were going through the different results, and then when we got to they kind of really wanted throughput. That's really what they wanted to know. And so when we went through the throughput data, I was getting somewhere in the mid-hundreds, maybe a low 200s or something like that, as far as throughput goes. But while I was presenting, the IT person or whatever was doing their own kind of test, and they were getting significantly lower numbers, right? They were getting somewhere, 60, 50, 40, something like that. And so why the discrepancy, right? And so early on, I started to realize that, well, number one, I don't know a lot about Wi-Fi because I can't figure out what's going on here. And then eventually I started to realize, oh, wait a minute, there's a big difference between, in this particular case, it was when I was surveying, right? So instead of surveying during the day, the customer wanted me to survey in the evening. And I was like, well, what difference is that going to make? Well, the difference was there was no load on the network. Load affects performance. And so the more utilization there is on the network, the less airtime there is. And so obviously my results were going to be radically different than what they were going to get, because they asked me to do the survey after hours. This also happened, and this was the last time I did throughput tests, when I did a survey for a customer that was an MSP that was putting in the wireless, and they asked me to go survey, to validate it and send the reports and all that. So I did that. While I was there, I ran into the end customer, and he was a pretty gruff person. Apparently, I didn't know there was all kinds of, sorry, I'm moving around too much. I'm getting out of the, so he was a pretty gruff man, but he was saying, are you doing throughput tests? And I said, no, I wasn't doing. He says, I told him that I want you to do throughput tests. And he pulled out a floor plan. He goes, I want 6 throughput tests on each floor, one here, one here, one here. And I said, okay, I can do that for you if you want. And so then I went ahead, did the survey, and then I would stop and I would do individual throughput tests in each location. And then when we met up later and we went through it and we were looking at the very large discrepancies between what he was doing and what I was doing, because he was getting He was doing an internet speed test. I was doing an ePerf, but he was getting like 350. And then he just started literally stomping around saying, this is why I told them, send people who know what they're doing and all of that. But the one thing I noticed was that all the results were relatively the same. They were all about 60 to 65 megabits per second. So I thought that was interesting. So I called my contact who was making changes that I told him, hey, you should do this and change. So he was the one who was actually looking over the system. And I said, hey, do you guys by any chance have rate limiting here? And it turned out they did. And if you paid extra or you got unlimited access, right? They took your Mac out of the whitelist and all of a sudden you could get full access to whatever was there. Because the consistency is what threw me off. It was just way too consistent everywhere. And so again, that was the last time I did it because I realized, you know what? When you do these tests, you're doing them with your device. So what if you have a 3 spatial stream, 11 AC device connected and you're using 80 megahertz channels? Well, you're getting close to, 800, 900, data rate, maybe not throughput, but you're getting really high throughput. But what if the customer has a single stream device? They're not going to get anything close to you. So that's when I started learning that these tests without any context really are very, very limiting. And they can really kind of put egg on your face, right? They make you look like kind of you don't know what you're talking about and you lose credibility. So the bad is when your credibility is on the line. So that's when we're talking about doing things like throughput tests with no context, testing with the wrong device, as I just mentioned, not testing under load. So if throughput is important, then obviously load is going to have an impact on that as well. And pings are not your friend, right? Because pings are great to tell you connectivity, but typically, especially the more utilization there is on the network, I keep moving around so much. Utilization there is on the network, you're going to have more variations in your ping than you do, let's say, on a wired network, right? So what are you actually seeing when you see pings? You're seeing contention, right? Or you can kind of get an indication of contention. This ping took a lot longer than that ping, those kinds of things. And so without the context, it's kind of hard to make use of active surveys. So when my students ask me, do you do active surveys? I say, yes, I do, but not. I'm teaching Ekahau, I say not in Ekahau. And the reason is not because it's not a good tool or anything, but it's because I've learned, I'm doing it with this device, my laptop or my iPad or whatever it is, and that might not be what the customer has. So a long time ago, I just stopped saying, I'm not gonna rely on that. That's not gonna be something that I'm gonna do. But what are some examples of things that active surveys that can have some value? And so things that I've done that I think are good in context, right? They actually help me give me the data that I need are things like AP and antenna coverage. That's the most common one, right? You place an AP and you on the channel, you set the channel, you set your power where you think you're going to be, maybe even different power levels so you can try different things, and you walk to see what is the coverage pattern of this AP. And so, for example, that might help you before you start a design to say, hey, I want to get some context here. I know I can put in a design and draw the walls, and the idea is the more information I get, the better my design's going to be. The best information is real information. So you could actually use an AP. You don't have to do every location, but to get an idea of kind of how this AP is going to cover. Antennas are another great example. We did a microchip manufacturing facility that had no wireless in their production facilities, and they wanted to add wireless, and they had the buildings, they had these things they call tunnels, full of like the back end of the chip making machines, the fabricators, and all this piping and everything. And I'm like, so we tried a couple of things. So I went there with an Omni, I went there with a directional. I tried different locations to see where do I get the best, the best pattern, the more consistent pattern. Some things I found out was that even though it looks like there's metal everywhere, and there was, an Omni went really far in that environment, way farther than I thought it would. And I thought I would really lose a lot of attenuation. But then I did a throughput test with context. So why were they putting the Wi-Fi there? The reason they wanted the Wi-Fi was because they were switching to iPads, and they were going to be doing, they wanted to do video sessions for support and training and things like that. And so they wanted the people to be there next to the machine, be able to show what's going on so they can give context to support and things like that, because when the fabricators are down, that costs money. So I already knew, okay, they're using iPads and video is what they're going to do. They were basically saying like Zoom or something like, basically that's what they were going to use, Zoom. So what I did was, okay, well, what are the requirements for Zoom? What's the latency? What's the throughput? And that gave me context. So while I was doing my AP on a stick, I could also do tests to see, okay, if I'm running video, what are we looking at as far as retries, for example, right? Are we able to get consistent data rates, and are we able to get relatively low retries? Because things like real-time services, you don't want really high retries. And so in that sense, I was able to get data that made sense, because I could do the throughput test with the device, or I can do the video call with the device, and I just use Wireshark to capture the data. And then out of those frames, how many of them, what's the percentage of retries? And what I found is with the Omni, even though I had way more coverage with the Omni, the retries were all over the place, right? So they were really high and well beyond the threshold of what we would need for Zoom. But when I went with the directional antenna, what I saw was it was more focused, and I was able to get more consistent data flow and much, much lower retries. And so that was a throughput test with context, right? I knew what I was testing for. Another thing is validate performance requirements. Again, what was I testing for? So I used a survey tool to capture coverage, how the RF is moving in the environment, but I used my Wireshark to capture the data flow so that we can do analysis and see, are our MCS rates staying relatively steady, right? Are we staying at higher MCS rates consistently, or are we dropping to low MCS and high MCS? Are our retry rates higher than is acceptable for the technology that we were using? So validating performance requirements is one. Comparing received sensitivity. So another one I know that people have talked about for years, in WLPC and other places, is about when we're designing for a specific device, if you're using a specific device to survey with, well, that device might perceive or see, or its view of the network will be different than maybe the device the customer is actually going to use. So another thing you could do is you could actually test receive sensitivity for devices to see what's the average receive sensitivity compared to your survey tool, and then you can create an offset or use an offset and just say, hey, my device saw neg 67 or neg 65 or neg 64, but their devices on average see neg 69, right? Maybe they're 5 or 6 or 7 dB off on average, right? So that's another example of where you can use a tool like this to get useful information. It's all about context. Wall attenuation, that's one that I think we're all familiar with, and I don't know if those guys are here from that new company, but that is creating that tool, but measuring the walls to get accurate data for your surveys, for your designs, right? So that our walls can be accurate, so that the design can be as accurate as it can be. So wall attenuation measurements would be another one that would be very important. And device compatibility or capability comparison. Actually, that kind of goes with validation performance. So, if I'm going to a customer and the customer says, hey, we have issues with voice, we're having choppy calls, we get disconnected, this and that happens, right? Now, I could test a device, I could do a packet capture, but generally what I'm going to do is if it's happening across the board is, well, let's survey first and let's see if we even meet the basic requirements for what we need. And if the answer is no, well, then we fix that. Once we fix it, and I validate it, then I can test with the device under load in the middle of the day when other people are on there, and that's my active survey. I'm not walking around with my survey device. My survey device is the customer's device that I'm using to validate, well, you couldn't do this thing before, can you do this thing now? And so make a call. Can we roam? Can we walk in and out of rooms? Are there places where it fails? Go back and look at the data and see, okay, oh, wait, I turned off an AP over here that turned on this corner, and now when I turn that corner, I no longer stay connected, we probably should turn that AP on if they need roaming to go down that hallway. So those are the kinds of things that can be very helpful. So another thing that I did, I think last year or the year before, was my business partner. He owns a manufacturing facility in where I live, he's an owner in one of the manufacturing facilities, and they were needed to replace everything as far as the network infrastructure and the wireless. So we did all of that as well, and it's a production facility. So one of the things that they wanted to do was they wanted to go all wireless, but they had all desktops there, right? And so they were relatively new. They didn't want to just go out and buy laptops or something like that. So what we wound up doing was say, well, why don't we use USB NICs? And so I said, well, I'm not so happy about that, but let's see what we can do. So what I did was I actually bought several. Oh, it's not showing my screen. Let me see. Hold on. Move to display. There we go. And now whatever I had was gone. Okay, let's try this one more time. Why is it gone? Where is everything? Oh, there it is. Let's try this again. Move to display. Okay, so what I did was I bought a series of adapters off of Amazon, just different vendors at different price points, and I did throughput tests with them in my office. So I set up an AP at a specific distance, specific power level, and then I used these different NICs, and I did 12 tests, and I took out the worst, and I took out the best, so that we had kind of more of an average. And then what I did is I wanted to look at, the first thing I looked at was the throughput, just the raw throughput. But I was also doing a Wireshark capture to capture the retries, how many retries we were getting when we were doing different things, throughput tests, video, streaming, moving a file, things like that. The other thing I did was I also changed, I have a second tab there, so I have vertical and I have horizontal. Some of them came with stands, some of them didn't, so I wanted to see how they worked best, right? And so what got the best performance. And so I did this for all the adapters. And the reason I did this was to say, okay, if we're going to go all wireless and if we're going to use these adapters, I want to know which adapter not just performs the best, but which one has the lowest retries, which one is going to be most consistent, right? Some of them have wildly different data rates. Some of them are fairly consistent. Some of them perform poorly all the time. Some of them perform much better later on. And so I was able to find, okay, the cheapest one that works well is here, and the best one that works overall is here, and then we can make a decision about which is going to be, hey, not only do we need to have it vertical, but we're going to get an extension cable to make sure it's up, and I don't want it in behind the computer. If the computer's on on the desk, on the top of the desk, maybe put it on top of the computer. If it's on the ground, put it on top of the bookshelf or the desk or something like that, so it has the best line of sight. But I was able to use that to figure out, okay, what is going to be the best adapter for them. And so that way, we bought those adapters, and that's what we used to connect the desktops. So the point of all this was just to say that active surveys are like kind of at the bottom of my list of what I do, right? When I do surveys, I focus on passive data to see everything that's around there, that holistic view. But when I need to get very specific, I can take advantage of active surveys, but you need to understand what is the context. What is it that the customer needs to happen? When does it need to happen? How do they use their devices, right? So I can test a device and say, yeah, this adapter works fine. I recommend you use this one. But then they go and they take the adapter and they put it like in a golf cart and underneath the front dash or something. And that's a whole different experience, right? So probably best to, if that's the way you're going to do it, if that's the way they want to do it, test like that. Go to their location and test and see what it looks like. Or maybe say, hey, I recommend that you put it up, get a nice long cable, maybe tape it to the outside so that you can have a nice line of sight or something like that. So it's all about, for me, it's all about context. And really, that's it. That's all I have. All right.